The scatterplot's a graph of two sets of data that shows some sort of relationship or connection or correlation between the two sets of data. If the connection or correlation between the two data sets is such that as one variable goes up, the other goes up or increases, then we call it a positive correlation. And at younger ages, as people grow, they get taller. So at age 5, maybe the height would be 40 inches, at 6, 44, 7, 48, then 10, 60. I had to make my 12 a 10 because I don't have a space over here to go up to 12, so that's why that's in yellow. So let's put these on the graph. At 5, we go over 5 and up 40. And that's how it works. It's like the x-axis and the y-axis. So 540. 644, and this is kind of rough. 748 and 1060 would be in this area. And then what you can see is if these points will not necessarily be lined up totally all on the same line, but if we would draw what's called a trend line, and would like to use a straight edge to do this, so just imagine I have one, it won't be very straight. We connect them in a way, or draw a line that kind of connect, maybe some points are joined, but there's a rather equal number of points above and below the line. So it could look like that. And that would be called a trend line. And with that, we could make predictions about how tall someone would be when they're 12 years old or 13. Of course, with this example, it only works up to about age 15, 16, when our growth tends to slow down. So this is a rather limited example, but you get the idea with it. Because two things are correlated, it's not a guarantee that one thing causes the other. For example, it's pretty widely accepted that as ice cream sales at the beach go up, the number of drownings go up. So if you take ice cream sales, put that in dollars. And I'm not going to try to name a number, which draw a general trend line. It would kind of go this way. Now, why would that be? Does that mean that ice cream sales cause drownings to occur? Of course not. When there's more people at the beach, there's more ice cream sales. And when there's more people at the beach, there's more people in the water. And when more people are in the water, then more people drown. So just because one thing goes up and the other thing goes up with it doesn't mean that one causes the other. People will try to convince you of that, so be careful when they're trying to argue with you and prove it with graphs and displays that one thing causes another. You have to think carefully and use logical reasoning. Don't get tricked by somebody who's trying to deceive you. A negative correlation occurs if the value of one data set increases and the other decreases. So it's kind of the opposite of positive correlation. By the way, increase, I should have mentioned this, increase means to get higher and decrease means to get lower. So when one value gets higher and the other gets lower, that's a negative correlation. So here's an example. You buy a bicycle and when you take it out of the store, it's worth $100. So at 0 years, which would be here, it's worth $100. So we're going to put 0, 100, which would be right here. Let me change that color. 0, 100. At 1 year of age is $50. 2 years, $40. 3 years, $30. And you can see it kind of is going to be a curve, but sort of a challenge of drawing a trend line is a little difficult, but we'll just kind of go right in there. So you can see that eventually it's not going to be worth hardly anything at all. But again, this is just sort of an example that's maybe not realistic. As the age gets higher, it actually might start to become valued as an antique. So the value could increase, and it would show a positive correlation after a certain number of years. But this is an example of, at least in the early years of the age of a bicycle, there's a negative correlation between age and value.